Good afternoon, grade 12s. Welcome to our telematics broadcast for this afternoon. It's so nice to have you here with us online, and we're really very happy that you are taking your studies seriously and that you are gearing up for your final examination that will take place in a few days' time. We also want to extend a very special welcome to those who are doing the second chance Matric program as well. Those are individuals who wrote grade 12 last year but would like to improve their marks, and so they are working very hard on their mathematics as well. And then we have a goodly number of teachers as well as tutors and parents who are joining us for this program this afternoon. This Matric Term 3 revision program is divided into 4 segments. And firstly, we're going to focus on statistics. So if you focus on the monitor now, you'll notice that in statistics, what we are going to be focusing on is paper 2 work. As you know, statistics occurs in paper 2, and in our revision booklet, you'll find information from pages 16 to page 26 that revolve around statistics. Now, please note, grade 12s, that all the statistics content from grades 10 through to 12 will be assessed in the final grade 12 examination. Well, what are we talking about? Well, we're talking about the following graphs that we find on page 16 in our revision booklet. Pie charts, line graphs, bar graphs, the histogram, you may remember doing this in grades 10 and 11, then the box and whisker diagram, the stem and leaf plot, and particularly from grade 11, the cumulative frequency curve, which is known as the ogive. Those are very important concepts. Bivariate data was a topic that was introduced to you in grade 11. Now, by means of this definition, bivariate data, we mean that this is data that consists of 2 variables that can be represented by means of scatter plots. Your teacher nicely explained that to you. So these dots represent all the data, and you notice there we have our y-axis and there we have our x-axis. In a very real sense, we have down here our independent variable, and on this axis here, we have our dependent variable. And if we look at this particular data set, we say that this represents a positive linear correlation. Looking across at this particular figure here, notice down like that, that is a negative correlation. Moving on, if we have data that is scattered all over the show like this, we can say, well, we don't have a positive linear association or a negative linear association. This indicates that there is no correlation in this bivariate data set. What about this particular one here? Well, you notice it goes up. It seems to have a positive linear association. And then coming down, it seems to be a negative linear correlation. But here we have what is called a non-linear correlation. So those are some concepts just to look out for. What is meant by correlation coefficient? This is a term that you've probably met in grade 12. Well, by the correlation coefficient, we mean the strength of the relationship between the 2 variables. In other words, what occurs on the x-axis and what occurs on the y-axis, one can say, right? So in other words, the independent variable and the dependent variable. What is the strength of the relationship between these 2 variables? And this is indicated by means of a small r. We'll notice that as we go through our program now. Moving on, the correlation coefficient has the following properties. Firstly, we must recognize that the correlation coefficient is a number that is found between -1 and +1. So in other words, we can say that the correlation coefficient R is greater than or equal to -1, or R is less than or equal to +1. That's how we write that, right? So it occurs between those 2 numbers, -1 and +1. Now, a strong positive linear correlation indicates that R is close to 1. Where we have R equal to, say, 0,93, that represents a strong positive linear correlation. What about a strong negative linear correlation? Well, in this case, the R is close to -1. So for example, if R is equal to minus 0.91. We say that that is an example of a strong negative linear correlation. Where there's no linear correlation or a weak linear correlation, R is located between minus 0.3 and positive 0.3. So let's keep those points in mind, especially the strong positive linear correlation and the strong negative linear correlation. The equation of least squares regression line is a concept that was studied in grade 12 in the South African curriculum. And the formula for the equation of least squares regression line is given by, as we can see on the monitor, y hat is equal to a plus bx. We may want to mention that this equation of least squares regression line belongs to the family of straight lines. Now we know the equation of a straight line, right, from analytical geometry. Y is equal to mx plus c. That's the equation of the linear function, or the equation of the straight line, one can say. But the equation of least squares regression line is in the same format, and yet it's somehow changed. Notice once again on the monitor, there we have y hat, this little copy, one can say, all right, on the y, that hat on the y is equal to a plus bx. In this case, the b represents the gradient, and the a, one can say, will represent the y-intercept if one extends that line to cut or to touch the y-axis. So let's remember this formula, which occurs on the information sheet. Y hat is equal to a plus bx. Moving on, two questions merit our attention now. What is meant by the equation of least squares regression line? We need to come to an understanding of that point. And secondly, how do we use the calculator to help us determine the equation of least squares regression line? Well, let's take our first question. As you can see from the monitor, a line can be drawn through the points to determine if there is a significant negative or positive correlation on a scatter plot. A line of best fit will not represent the data perfectly, but it will give us an idea of the trend. The line of best fit is also called the regression line. This line will always pass through the points bar x, semicolon, bar y, where bar x is the mean or average of the x values, and bar y is the mean or the average of the y values. So if we look at this particular diagram here, the black dots represent our data set in a scatter plot. If we find the average of all the x values, find that point, and we find the average of all the y values, then we connect this line through that, and that's how we get our regression line, or what is called the line of best fit. Notice this particular diagram here. Here we have a data, here we have data, and so the story goes, these scores. The aim of the least squares regression line, is to make the total of the square of the errors as small as possible. The straight line minimizes the sum of the squared errors. When we square each of those errors and add them up, the total is as small as possible. Now you may be saying to yourself, man, that is all so complicated. How do I really go about this? You know, that's all so technical. Well, grade 12s, don't worry. That's why we have this revision program. It's to help you capture the main points in what you've learned during this year. Let's now go into an example as to how we calculate the equation of least squares regression line. And what we're going to do, we're going to take an example that occurred in the DBE February-March 2018, paper 2. You may want to reference this after this program and work through this yourself as well. This was question number 2. Notice how that question read. It said, the table below shows the number of hours that a sales representative of a company spent with each of his 9 clients in 1 year, and the values of sales in thousands of rands for that client. So we're given this table. There we have our number of hours. Notice 30, 50, 80, 100, 120, and so the story goes. And here we have the value of sales in thousands of rands. Please don't forget that detail. That's important. In thousands of rands. So how do we go about this? Well, what I'm going to do, I have my calculator right here, and I encourage you to have your calculator in hand as well. What we're going to do now is we're going to see how the calculator can help us as we calculate the equation of least squares regression line, right? So before we look at the questions, let's first handle this particular part of the screen. So what I encourage you to do, you've got your calculator right there. I'd like you to go to mode setup if you're using the Casio FX82ZA Plus, and you press mode setup and you go to option number 2, which is the statistics mode. When you get to option number 2, you'll notice that there are 8 options that are given us there. We would like option number 2 because that one is the one that deals with the equation of least squares regression line. You will then be introduced to 2 columns. One column represents X and the other column represents Y. And what I'm going to do right now, I'm going to encode or punch in every figure there under the X column, and then I'm going to go to the Y column and punch in the figures under the Y column. So my number of hours starts with 30 is equal to, and then I have 50 is equal to, and then I have 80 equal to, 100 equal to, 120 equal to, 150 is equal to, 190 is equal to, 220, and finally 260. And I just make sure to see that there are 9 scores because there were 9 clients. You may remember that from the question, and I have that. Now I go right back to the top where I have the first one that I punched in, and I go across, and now I put in the value of sales, and the figures are given me in that table. Firstly, I have 270, and then I have 275, and after each score I must press equal to, which enters it into the calculator. Next, 376 is equal to, and then 100 is equal to, then I have 420 equals 602, I beg your pardon, 602 is equal to, and then I have 684, and then 800, and then 820, and I check, yes, I've got 9 for the X, and I've got 9 for the Y, so all my data has been entered right there. So I've entered it in the calculator. How do I proceed from this point? Well, let's just leave that there. The calculator will not forget that data. Let's have a look at our questions. So, moving forward, there we see our scatter plot, right? They give us the scatter plot, and the data that we've just seen in the table is represented in the scatter plot right there. Now let's have a look at our questions. In that question paper, for 1 mark, the first question said, identify an outlier in the data above. So if I go back to my scatter plot, I can see that all these scores are almost in a straight line here. But this one here seems to be out of that line. And if I look at what are its coordinates, there I have 100, 100 there, and there I have 100 there. So all I say is the outlier is 100 semicolon 100. So if I write that down here, the outlier, in other words, it's that point that is away from the data set is 100 semicolon 100. Right, there we go. That's my outlier. And once I've done that, I'm sure that I've got my 1 mark. Now question 2.2 says, calculate the equation of the least squares regression line of the data set. So I go back to my calculator now. Remember, I punched everything in, so I referred to my calculator. Now, believe it or not, grade 12s, all I need to do is press AC. In other words, I cancel. Don't be scared to cancel. AC means cancel. The calculator still has retained those data scores. And what I do now is I press this button here that says Shift, and this one where it says number 1. And because right above that, you'll notice that that is giving me the statistics mode, the analysis for the data that I've punched into the calculator. And what I'm interested in now is option number 5. Notice it says REG. That stands for regression, right? Regression. And so there we have regression. So I press option number 5, and as you can see there, now I have a few interesting details. I have number 1 says that's my A. Number 2 is B. So if I'm looking for the value of A, there it is here. I just press number 1. If I'm looking for the value of B, I press that. If I'm looking for R, the correlation coefficient, well, then I just press 3. And if I'm looking for 4 and 5, well, I just press that. Well, let me write down my value of A. So I press 1 and I say equal to. And there you see on the calculator there, my value of A is equal to 94,5027 ... Let's put it like that. Okay. Now I cancel that. Then I go Shift 1 again, and I go to option 5, and I'm looking for the value of B. Right? And I press number 2. That's equal to, and there I get my value of B is equal to 2,9137 ... Right. Now, those are my two values. So now the question said, I'll put my calculator aside, I'll be returning to that in a moment. The question says, calculate the equation of least squares regression line. Grade 12s, once I've got my A and my B, I can write down my equation of least squares regression line. And the equation is none other than y hat, you may remember that, is equal to A plus BX. And now let me substitute. And what I'm going to do, I'm going to round off to 2 decimal places for each. So in other words, y hat is equal to, when I look at this particular one here, 94,5027, that's going to be 94,50, let's just put it like that, plus, and my value of B is going to be 2,91, and then I put my X. That is the equation, my equation of least squares regression line for this data set right here. Okay, notice you'll get a mark for the value of A, you'll get a mark for the value of B, and you'll get a mark for writing this in the correct format, the equation of least squares regression line, because that is what the question explored. Now, let me look at question number 2.3. Now that I've got that, the question reads, the sales representative forgot to record the sales of one of his clients. Predict the value of the client's sales in thousands of rands if he spent 240 hours with him during the year. Well, grade 12s, this is a very easy question. And what we do now is we take our equation of least squares regression line. I'm going to write it once again. Y hat is equal to 94,50 plus 2,91. And now the question said, the sales representative spent 240 hours with him. So I must substitute X. For X, I must substitute 240 right there. And then I must find the answer for Y hat. Right, so now I take my calculator, now that I've got that, and it works out to be the following. When I take my calculator, you'll notice I have 94.5 plus 2,91, and in brackets I put 240, close my brackets, and equal to, and there you see the answer on the calculator. The answer is none other than 792,90, but that's not my final answer. So the calculator gives me 792,9. The question says I must find or predict the value in thousands of rands. So what I need to do with this answer is I now need to multiply this by 1,000, and there my final answer is in rand, right? I'm going to have rand 792,900. In other words, 792,900 rand. That is my final answer for question 2.3. Right, then finally, question 2.4 says, what is the expected increase in sales for each additional hour spent with the client? You may remember when I introduced the different variables, I mentioned that B represents the gradient. What this question is actually exploring is the value of B. So I write down the value of B is equal to, as you've seen, 2,91. And the calculator initially gave us 2,9137. You may remember that, right? So let's put 37 and we stop there. Now, what is the expected increase in sales for each additional hour spent with the client? Well, if I take that particular value, and that's 2,9137, and multiply that by 1,000, notice what I get. I get a rand value of 2,913 rand and 70 cents, right? That is the particular answer there. Some could round it off to 2,914. That's also within the ballpark. There's no doubt about that. But the important point is to multiply it by 1,000 because our question explores in thousands of rands. What have we been saying here today, grade 12s? We've been saying that the equation of least squares regression line is given by y hat is equal to a plus bx. Do you remember how we use the calculator in calculating that? We first go to statistics mode, and then we enter the data after we've chosen the equation of least squares regression line. And from there, things flow very, very nicely. Grade 12s, this is an important question in paper 2. Make sure you understand the principles as to how to calculate the equation of least squares regression line. So if we just look at our different solutions, there we had our outlier, there was 100, semicolon 100. There we have the second point, the equation of least squares regression line. You may remember we had that, we worked to that. And then there we have the value, 793,000, right? And then finally, there we have this here, same answers as above. So practice, practice, practice. In everything you do, plan your work, then work your plan. All the best, grade 12s. We know you'll do very, very well with your paper 2. In the next program, we're going to focus on financial mathematics and how you can score very good marks. And we'll go through a review of term 3 work in that connection. Until then, bye-bye.